Okay, so we're going to look at 4.1, which is what we covered before our spring break. We're going to look at question 7. And question 7, I picked it out because a lot of times students get confused with the exponents. So let's see what we've got here. Okay, now there are different ways of solving these. We have to apply our rules of exponents. So what we can do is distribute this minus 3 through. Okay, and it's a power, so we can be distributed through. That's going to then leave me with 5 to the minus third power over 2 to the minus third power. Now, what we have to be careful of with these is the negative exponents. So how do we handle negative exponents? Right, well, we talked about this before. Whenever we have a negative exponent on the top, it goes down to the bottom. So this 5 to the negative third is going to go down, and this 2 to the negative third comes up to the top. And so then they get rewritten as positive exponents. So I can now rewrite this as 2 to the third over 5 to the third. Now, a lot of times students make a mistake here. It is not 2 times 3, it is 2 to the third power. And what does that mean if I write it out? That is 2 times 2 times 2. And that gives you then 8. And 5 to the third power is 5 times 5 times 5, which is then 125. Okay, so that's what we've got there. That's going to be your answer. And so your answer is going to simply then be 8 over 125. And that's all you need to do. And that's as far as you can then break it down. Okay. Let's look at question 17. Question 17, we want to rewrite this in standard notation. Or sorry, in scientific notation, because this is in standard notation. And we want to write this one in scientific notation. And we've got 4 zeros, it looks like. 1, 2, 3, 4. And then a 1, 9, 8, 1, 2. So what we want to do is write this in scientific notation. Now, smaller numbers like this one that are less than 1, they're going to have a negative power of 10. And what we do is we count the number of places to get one digit and then the decimal point. So we're going to go 1, 2, 3, 4, 5 places, because you always want one digit and then the decimal. And so that is 1.9812, and we had to move it 1, 2, 3, 4, 5 places over. So that's going to be times 10 to the negative 5th power. What we need to make sure of is that you have one digit and one digit only, and then the decimal point. So always make sure you get one digit in front. Question 20 does the opposite. So question 20, we're going to rewrite this one in standard notation. And it's times 10 to the 4th power, and it's a positive exponent here, so that's going to make it a large number. Okay, so we're going to have to add on 4 zeros. So here we are at minus 7.042, and we're going to have to move this 4 places. So we're going to go 1, 2, 3, 4. And that negative is still along with it out in front. So that looks like that's going to be a negative 70,420. So there is your answer on that. Are there any others for us to look at out of that 4.1? Anything else? We need to look at? Okay, and these, I think, once you get used to the rules, are not that difficult. The next section, for a lot of you, is going to be a review. The next section is pretty easy. The next section is multiplying polynomials. So we're going to be learning how to multiply out these polynomials. We'll just start with the simpler one first. This section is very easy. You probably have done this before. Well, we need to go ahead and multiply out this polynomial. So what we're going to do is we're going to distribute that 5x through. Now the powers are going to add together, and the exponents are going to multiply. Or not the exponents, the powers add together, the coefficients, the numbers in front, these multiply together. So first thing we do is 5 times 3. Well, 5 times 3, that makes it a 15. And then how many x's do we have? We have 1 and 2 more. That makes it 15x cubed there. Then we have 5 times a negative 8. That's a negative 40. And x times x, well, that makes it x squared. And 5 times 2, well, that makes it a 10. And don't forget to bring your x with it. So that's how you distribute. Let's do another one, and then we'll talk about the FOIL method. So let's go ahead and multiply this one out. What we're doing is we're going to multiply let's see what we've got here. Well, 8 times that 3. So 8 times 3. 8 times 3, that makes it a 24. And then we'll look at the x's. So these add together. So we have 9 x's out in front. 2 more, well, that makes it an x to the 11th power. How many y's do we have? We have 5, and 4 more makes it y to the 9th. And z's, we have 3, and there's no exponent, so we know that's a 1. So 3 and 1 makes it z to the 4th power. We have a minus. 8 times 2, well, that makes it a 16. How many x's do we have? Well, we have x to the 9th. And 1 more makes it x to the 10th. How many y's do we have? We have 5, and 9 more makes it y to the 14th power, because these add together. And z's, we have 3 and 3 more. Well, that makes it then z to the what? Z to the 6th. We can't combine these together because they're different. These are what are called unlike terms. They cannot be combined together. Now, what happens if you have 2 terms out front? Terms are separated by addition and subtraction. Well, if you have more than one term, if you have two or more, you're going to have to use what's called the FOIL method. So we're going to learn how to use the FOIL method here. Well, if I want to use the FOIL method, we think about what the letters mean. The F, that means the first times the first. Okay, so FOIL, first times first is here. 3 times 8, so 3 times 8, that makes it a 24. And x times x, that makes it a x squared. And we do the O, which is the outside, times the outside. Right? So that's 3x times a negative 1. So that's a minus 3x. Then we do the inside times the inside. And that's 5 times 8. That's a 40x. And then finally 5 times a negative 1. Well, that makes it then a negative 5. Now, when you FOIL, a lot of times you can put the middles together. Are the middles the same? Yes, the middles are what are called like terms because they both have the variable x. So those can go together, and that means my final answer would be 24x squared plus 37x minus 5. You're going to be foiling a lot, so we need to make sure that we're comfortable with foiling. So we're going to do a couple more of these, and then we'll learn another technique when there's more than just 2 terms and 2 terms. Let's do another one. And let's try to FOIL this one out. And FOIL, again, the F stands for the first times the first. So I take the first times the first, and that's 5 times that 6, and 5 times that 6, that's a 30. And then we have a Z, and we have an X. Then we do the outside times the outside, and that's going to be 5 times 5, that is 25, Z. Then we have the inside times the inside. Now make sure you're careful with that negative there. And negative 3 times 6, well, that's a negative 18. And that looks like XY there. And then we have last times the last. And that's negative 3 times 5. That makes it a negative 15. And the Y is with it. Now, can we combine any of the terms together? No. Many times you can put the middles together, but these we cannot, right? They are different. So a lot of times they go together, but not always. Nothing goes together because this is a ZX. It can't go with that one, and it can't go with that one. This one's just a Y, so it can't go with that one. So this is as far as you can go. Now, for squares, we write them out. So let's say I give you 5x squared minus 9 quantity squared. Now, a lot of times, students make a mistake here, and they just say, well, I can distribute this 2 through. And you cannot do that. Parentheses have to be done first. And this is a quantity squared, so what this actually means is there's two of them. Just like we did when we wrote out the numbers. When we squared a number, remember we wrote it out twice. Same concept here. Now we're going to write this out twice, just like that. Okay, so write it out twice, and now what do? Well, now we go ahead and we FOIL. So first times the first. 5 times 5, that's a 25. The powers add together, so that's 2, and 2 more makes it then x to the 4th. Then we've got 5 times a negative 9, and 5 times a negative 9, well, that's a minus 45, and that's going to be an x squared there. We do the inside. Be careful about that negative. Negative 9 times 5, that's another negative 45. And that's again going to be an x squared there. And then finally, we have the last times the last. And watch your signs. Negative and negative makes it then a positive. That's another commonly made mistake. So that's going to be a positive 81. Now, can I put the middles together in this case? Yes, because those are the same. And what's my final answer going to be? Well, it will be 25x to the 4th minus 90x squared, because those can go together, and a plus 81. And that is going to be your final FOILed out answer. Now, what happens if there's something in front? So we've been foiling. What happens if there's a number in front? Let's say we have a 3x squared times 4x minus 1, 2x plus 7. Well, if I gave you this, you want to FOIL first. So the first thing I'm going to do is I'm going to FOIL first. The very last thing you do is distribute. So we're going to FOIL first because parentheses go first. So let's FOIL it out. And 4 times 2, well, that makes it an 8. And x times x is an x squared. 4 times 7. 4 times 7, that makes it a 28. X there. Inside and inside, watch your sign, because that is a negative there. Minus 1 times 2x, that makes it a minus 2x there. And finally, last times last is a minus 1 times 7. Well, that's a minus 7. The middles, again, can go together. Now we have 8x squared plus, we're going to add these together, 26x, because 28 minus 2 makes it a 26, and a minus 7. And do not forget what is still out front. What's still out front is that 3x squared. Is everyone okay with that so far? So we just always FOIL first. If you distribute through early, you might make a mistake, because it actually would only go through the first set of parentheses. A lot of times those students try to do it through everything, and so that is why I think you should just FOIL it first. Now what do? Now we distribute, and we're done. So 3 times 8, that makes it a 24. X squared, another x squared. Well, that makes it now x to the, adding them together, 4th power. Then we have 26 times that 3. And that's going to make it now a 78x. And 2 more makes it an x cubed. And finally, 3 times a negative 7. Well, that makes it a minus 21. x squared. And that is all you have to do. So is everyone okay with how we FOIL here, right? Pretty simple, pretty easy. Many times the middles will go together, but not always. So you have to be careful with that. Now, what happens if we have something that is too big to FOIL? Now, for it to FOIL, when we talk about foiling, let's look at this one. Okay, we FOILed this one out here. How many pieces did I have? I have 1, 2, 3, 4 pieces, right? 4 pieces or parts, 4 letters in FOIL. What happens if there's more than 4? Well, if there's more than 4, then we have to come up with another way of working these out. And we're going to be using the box method. So this one's going to be too large to FOIL. Right? Because FOIL has 4 letters, and we need 4 different pieces. And this one has 1, 2, 3, 4, 5. So it is too big to FOIL. If we can't FOIL, then what we're going to use is we're going to use the rectangle method. Or the box method. And what we do is we draw a rectangle. And I usually write the smaller one down the side. So that's going to be a 3x and a minus 1 down the side. And then I'll write the larger one across the top. And that is a 4x squared, a 2x, and a minus 5. Some textbooks call this lattice multiplication. I just call it the box method. And now we just simply fill it in. So we're going to go ahead and fill this in here. We've got 3 times 4. Well, 3 times 4, that makes it a 12. X and x squared, that makes it an x cubed. 3 times 2, that makes it a 6. X and x makes it an x squared there. 3 times a minus 5, well, that makes it a minus 15. X. Is everyone okay with how I'm getting the numbers? Okay. Next row, same procedure. Minus 1 times 4x, that makes it a minus 4x squared. Minus 1 times 2x, that makes it a minus 2x. Minus 1 and minus 5, negative and negative makes it a positive 5. Is everyone okay with how I did that? Pretty simple. Now, I like this method because now we just add on the diagonals. We always start in the upper left-hand corner. And we see what can go together. So what we start with is a 12x cubed. So that's up here, so that's gone. Now, a lot of times the diagonals can go together. These are both x squareds. So we have a 6 and a minus 4. Well, that makes it a positive 2x squared because those are adding together. And then we go here, minus 15 and minus 2. That makes it a minus 17x here. And what's left over all by itself on the end is the 5. And there is your final multiplied out answer. If it's got more parts, then we just expand the size. So let's do one more of these. Okay, this one's going to be a 3 by 3. And Then we'll go back and look at how we handle a cube. So again, this one's going to be too big to FOIL. How about we look at x squared minus 3x plus 4 times 2x squared minus 5x plus 1. And let's put a minus 3x squared out in front. Now again, this one has too many pieces to FOIL. So we're going to use the box method first. So we're going to do the box method on this. Now this is going to make it a square because we have 3 across the top and 3 down the side. It doesn't matter which ones go across the top and which ones go down the side. It doesn't matter. So I'll just write the first one across the top, and the second one down the side. That makes our grid here. A little bit time consuming, but it is not difficult at all. Now we just fill it in by multiplying. So 2x squared times another x squared, that makes it a 2x to the 4th power. 2 times negative 3, that makes it a negative 6. X squared and another x, that makes it x cubed. 2 times 4, that makes it an 8, x squared there. Minus 5x times an x squared, that makes it a minus 5, x cubed. Negative and negative makes it a positive. X and x makes it an x squared there. Minus 5 times 4, that makes it a minus 20x. And then 1 times anything is just itself. So 1 times x squared is an x squared. 1 times a minus 3x is a minus 3x. And 1 times 4 is a 4. We do the same procedure that we just did on the last one. We're going to add on these diagonals. You always start in the upper left corner. So we're going to start here with a 2x to the 4th power, gone. Now, look at your diagonals. These should be the same. Make sure that they are. These are both x cubes here, so they can go together. 6 and 5 makes it an 11, both negative. So that makes that a minus 11, x cubed. Gone and gone. Then we do this diagonal. And remember, there's a 1 in front of this x squared here. So we have 8, 15, and 1. So that's going to be 9 plus 15. 9 plus 15 should make that a 24, isn't it? Because we have 8 and 1 and 15. Yep, that makes it a positive 24. And that's going to be x squared. So gone, gone, gone. And then we have a minus 20 and a minus 3. Well, that makes it a minus 23x there. And then by itself, we have a 4. So there is part of our answer, but we are not completely done yet. Why not? Because do not forget, we still have that minus 3x squared out in front. So we have to bring that down, distribute it through. This is going to give us our final answer. So don't forget to bring it down. Be careful with your signs. Minus 3 times 2, that makes it a minus 6. We have 2 x's, 4 more makes it x to the 6th. Double negative makes it a positive. 3 times 11, that makes it a 33. X to the 5th. Then we have minus 3 times 24. That should make it a minus 72. X to the 4th there. Double negative makes that positive. And 23 times 3, that makes it a 69. X, it looks like, cubed. And then the last piece is a minus 12x squared. So that is all we can do. How do you know to stop? So here's what happens. Is sometimes students try to do more than what they need to. How do I know I can stop? Can I combine any of these together? No. Why not? All the powers are different, right? So that's how you know when you can stop. Nothing can be added together. We used all the pieces, we distributed through, and that's all you can do. We'll do one more, and this one's going to be a cube. We did a square earlier. Now we're going to work with the cube. So I want you to multiply this out. All the directions are just going to be find the product or just multiply. So that's all we're doing. This section is just multiplying. Now, just like we did earlier with the squares, we have to write this cube out. So that's going to be a 2x minus 5, 2x minus 5, and 2x minus 5. We want to group things together, so we're going to group the first two together here, and we're going to FOIL. So let's group the first two parentheses together, and let's FOIL all of this out, and see what we're then left with. Be very careful with your signs when you FOIL. 2 times 2, well, that makes it a 4. X and x makes it a x squared. So we have 4x squared there. Then we have a 2x times a negative 5. Well, that makes it a minus 10x. Negative 5 times a positive 2x. That's a minus 10x. And watch your signs here. Negative and negative makes it a positive 25. The middles can go together. And that leaves you then with a 4x squared minus 20x plus 25. And what's still out in front of it? Well, out in front we would have a 2x minus 5. So let me move this up so we can see here. Sorry about that. Now what are we going to do? We just did these earlier. So we just did one of these earlier. What are we going to do? We need to finish it, right? We need to get rid of our parentheses. We cannot FOIL because it is too large to FOIL. So we're going to have to use the box or the rectangle method. It doesn't matter which one goes across the top and which one goes down the side. I usually write the larger one across the top just like this. The smaller one will go down the side. And now we fill it in. So we wrote it out, we FOILed, we combined. Now we have to use the box method. 2 times 4, that makes it an 8x cubed. 2 times a negative 20, well, that makes it a negative 40x there. Squared, sorry about that. Make sure it's squared there. Because x times x, again, that makes it an x squared. 2 times 25, well, that is 50x. And then we've got a minus 20x squared down here. Negative and negative makes it a positive 100x here. Negative and positive makes it a minus 125. Let's go ahead now, combine terms together, and we are finished. So now we have an 8x cubed gone. How about x squared? These can go together, and that makes it a minus 60x squared here. Gone, gone. 50 and 100, that makes it a 150x. Gone, gone. And what's left over by itself? 125. We've got some time left. We're going to start the next section. We're going to learn how to do the opposite. We're going to be factoring. Chapter 5 is factoring. And we are going to spend a large amount of time on factoring. Factoring is the most important concept that you need to be successful in college algebra, or at least one of the most important concepts. So we're going to learn how to factor. Now, this is basically the opposite of multiplication. Okay, we're going to be taking out what's in common. And we're going to start off with learning how to factor the greatest common factor. So we're going to take out the greatest common factor. So we're going to take out our greatest common factor here. So we're going to start off with a really simple one. And we're going to take out what these have in common. So the first thing I do is I look at my numbers. And I have a 10 and I have a 5. What do a 10 and 5 have in common? What number do they have in common? They both have a 5, don't they? So I'm going to be factoring out a 5. And then we look at the variables. Now these both have the variable x. And you always take out the smallest power. So this is an x squared. And this one's just an x. So we're going to take out a 5x. Now, what's left over? Well, we divide. 10 divided by 2. 10 divided by 2, 10 divided by 5, that's a 2. And I have an x squared. I take an x out, so that leaves you with a 2x. We're dividing. Our negative sign comes down. 5 divided by 5 is 1. The x's are gone, so that leaves you then with the negative 1. We're going to do another one. Take out the greatest common factor. So this one, we need to find the number that's in common first. So I first look at my numbers in front, my coefficients. Numbers in front are called the coefficients here. And I look at all of them. I have a 4, an 8, and a 12. Well, these all have a 4 in common. We want to take out the largest number that goes into all of them. And then we look at the variables next. So these all have an x. And so what's my smallest power? You always take out the smallest power. So the smallest power is an x squared there. So the 4x squared is going to come out. I cannot take out a y. Why can I not take out a y? Well, this last piece, it doesn't have a y with it. Okay, so it cannot come out. So now what's left over? We divide. Go ahead and write your signs down. That's going to be a minus and a minus here. 4 divided by 4, that's gone. X to the 5th, take 2 of them out. That leaves you with an x cubed. We still have the y squared there. Next, 8 divided by 4. Well, 8 divided by 4 is a 2. We have an x cubed. Taking 2 of them out, that leaves you with an x and a y. Last one, 12 divided by 4. Well, 12 divided by 4, that is a 3. The x squareds come out. And so what's left over is just then a negative 3 there. So this would be your final answer after we have factored. Let's do some more of these. Let's do one more, and then we'll look at how to handle groupings. So let's try to factor this one out. And again, we're going to take out the greatest common factor. A lot of times in the directions we'll just say factor. So first thing I look at is I look at my numbers. Now there is times when nothing comes out. No number can come out. 3, a 9, and a 5. They have nothing in common. But we can here go ahead and take out some variables. First off, they all have the variable x. And what we want is we want the smallest power of that x. So what's our smallest one? It looks like it's an x to the 4th. So that's going to come out. They all have y's in common. Smallest power is just a 1, so that's just a y that comes out. And then we have our z's here. So smallest power, z to the 7th, comes out. Now let's see what's left over. 3 stays. What about the x's? We have 9, take away 4. That leaves you with an x to the 5th there. Y's, we have 7, take away 1. That leaves you with the 6th. And z's, we have 10, take away 7. That leaves you with a cube. Then we have a minus 9. X's, we have 9 of them. Take out 4. That again leaves you with an x to the 5th. Y's, we have 2. Take out 1. That leaves you with a y. Z's, we have 8. Take out 7. That leaves you with a z. Finally, we have a 5. Okay. X to the 4th is gone, right? Y is gone. Z is gone. So that's it. It's just going to then leave you with that plus 5 there. Is everyone okay with how I factored that out? Now we're going to learn how to factor groupings when they're in common. So what do you notice about these? Now, it doesn't just have to be a variable that's in common. It can be an entire set of parentheses that's in common. So it looks like these both have an x plus 2 in common, don't they? Right? There's two sets of those, x plus 2's. So that's going to come out. So I'm going to put the x plus 2 out in front. And then I like to use brackets for what's left over. That way I remember I have to simplify this down a little bit. So the x plus 2 and x plus 2's are gone. So what's left over? Well, we can just drop our parentheses. And that gives you a 4x minus 3 from that one. And then a 2x minus 1 from the second. Right? We just cross them out. We just crossed them out and we wrote down what was left over. Now we can combine together. Let's see what we've got here. How many x's do we have? We have a 4x and a 2x. That leaves you then with a 6x. And then we have a minus 3 and a minus 1. That makes it a minus 4. A lot of times, students stop here, but you can actually go a little bit further. Go one more step. Let's look inside of our brackets here. Inside of the brackets, what numbers do I have? I have a 6 and a 4, right? And what do 6 and 4 have in common? Well, they have a 2 in common, don't they? So what I've got underlined right here, I can factor a 2 out. So I'm going to take a 2 out in front, put it out in front of all of it. I still have an x plus 2 left over. And then I'm going to replace now, since we factored it out completely, I'm going to replace the brackets with parentheses. And so 6 divided by 2, that leaves you with a 3x. And a minus 4 divided by 2, that leaves you with a minus 2. Now, how do you know when to stop? A lot of times students struggle with knowing when you're finished. How do I know I'm finished? First off, I look. X plus 2. Anything in common in this set of parentheses? No. 3x minus 2. Do they have anything in common number-wise? No. Nothing can come out. Nothing can be added together. So I know I'm done. Let's do another one. This one's a little bit different. Same concept though. What can we do here? 3x minus 2, 3x minus 2. Are those the same? Yes. So that's going to come out. That's going to come out as a 3x minus 2. Gone. Gone. What's left over? Use brackets here so I remember to check the factor. And that's an m squared minus 9 to the 4th. I, again, am not done. Because look inside of your brackets. What can come out of here? Can anyone tell me? Looking inside the square brackets, can anyone tell me what they have in common? Yep, they both have the variable m. And what's the smallest power? M squared. So I'm going to take out an m squared. And that leaves you then with a 3x minus 2. We're done, so I'm going to use parentheses. And what's left over here is a 4, right, because that m squared came out, minus 9m squared. And that is as far as you can go. Now we're going to talk quickly about factoring by grouping. And I'll pick a couple of these from our textbook. This way they factor out nicely. So I'll just pick a couple to write up on the screen here. And this is going to be factoring by grouping. Now, how we factor is based upon the number of terms that we have. And if you have 4 terms, you factor by grouping. And we're going to do several of these. These are actually on page 348. And we'll start with 54. So we count the number of terms, and that tells us how to proceed. And so on Thursday, we're going to learn about 3 terms and 2 terms. We start with 4 terms today, because it's actually the easiest one. And if we have 4 terms, we factor it by grouping. So we group the first 2 pieces together, and we see what they have in common. So we're going to group the first 2 together. So if I group the first 2 together that I've got underlined here, what do these have in common? Well, it looks like they both have a 3 in common. And they also have an m in common. So a 3 and an m comes out, and that leaves you with an a plus b. We do the next 2. And what do these have in common? Well, the next 2, they have a 2 in common and a b in common. And that leaves you then with the same a plus b, doesn't it? Now, we just did this a moment ago. Here's how you know if you did it correctly. These parentheses had better be the same. If they are different, you made a mistake. Are my parentheses the same? Yes. So what's going to come out? A plus b. And what's left over? 3m plus 2b. That's it. So it builds on what we have just done a moment ago. Let's do another one. How about we look at 62? Now, sometimes you may have to rearrange the order, or you may have to factor out a negative. So let's look at 62. So we have a 2 looks like a cubed plus a squared minus 14a minus 7. So move this up so we can see what we have here. And again, this has 4 terms, so we're going to factor by grouping. Grouping the first two together, what can I factor out? Can anyone tell me? What would you factor out of here? What do these have in common? These both have an a, don't they? And what's my smallest power? Smallest power is going to be an a squared. So what can come out? A squared. What's left over? 2. We have 3 of these. Take 2 out. So that leaves you with a 2a. And that goes completely away. So that leaves you then with a 1, doesn't it? Now look at the next 2 pieces. Notice how those are both negative, aren't they? We want to factor out so it looks like this. In this case, they're both positive. So how can we fix that? Well, we're going to have to factor out a negative number, right? They're both negative. So let's factor out a negative 7, because 7 and 14 both have a 7 in common. So I'm going to factor out this negative 7. And negative 14 divided by negative 7, well, that leaves you with a positive 2. The a comes down. Negative 7 divided by negative 7. Negative and negative makes it a positive 1. Now we know what to do. Because are my parentheses the same here? Yes, they are. So 2a plus 1 comes out. Gone. Gone. And what's left over? A squared minus 7. Let's try another one. Let's look at, how about question 73? Again, factor by grouping for these. If you have 4 terms, you've got to factor by grouping. So we need a 4a cubed, a minus 4a squared, b squared, a positive 8ab, and a minus 8b cubed. I picked this one because before we do anything else, we need to see if they have something in common. Now, that could be a number, that could be a variable in common, or both. So let's look and see what we've got here. We have a 4, an 8, and an 8. Well, what do 4 and 8 have in common? They have a 4 in common, right? So you always want to take out that greatest common factor. So 4 is in common with all of it. So I'm going to take a 4 out. Can I take any variables out? No, because that one doesn't have an a. So the only thing that can come out is a 4. That leaves me then with 4, or sorry, not 4, that leaves, let me write it here. That leaves you with a cubed, right, because that 4 came out, minus a squared, b squared. What about the 8? Well, 8 divided by 4, that leaves you with a 2ab. And minus 8 divided by 4, that leaves you with a minus 2b cubed. So, and I just put parentheses, so remember, this 4 is out in front. Now, let's factor this by grouping. So the first two pieces, what can come out of here? Well, it looks like these have an a in common, and the smallest power is an a squared. So I'm going to take out an a squared. And if I take out an a squared, well, that leaves me then with an a minus b squared. Repeating the process here, these both have a 2 in common. So I'm going to take out that 2, and they have a b in common. So that leaves you then with a minus b squared. And what do we know? Are these exactly the same? Yes, they are. So that comes down as an a minus b squared. Gone and gone. And what's left over? A squared plus 2b. What's in front of all of it now? 4. And that is your final factored answer. We're going to look at one more of these, and then we'll talk about what it means to be factored. So then we're going to go over what's factored and what is not factored. So let's do one more of these, and then we'll talk about factored. What's factored, what's not factored. Let's look here at, how about question 76? That'll work. And question 76 is 3m squared n cubed. We have a plus 15 m squared n. And then we've got a minus 2 m squared n squared. And then we have a minus 10 m squared, it looks like. First off, can I factor any number out? No, because we have a 3, a 15, 2, and a 10. Nothing's in common with all of them. Do we have a variable in common? I think we do, don't we? Let's look now at the variables. All of these have the same variable in common, and all of them have an m squared in common. So let's factor out that m squared. So that's going to come out in front as an m squared. And then that's going to leave me then with 3n cubed plus 15n minus 2n squared minus 10 by itself, right? Because that m squared came out. Now we should know what to do. Let's factor. When I look at these two grouped together here, 3 and a 15, they have a 3 in common. N cubed and an n. We'll take out a single n. And that's then going to leave you with, factoring that 3 out, that's going to then leave you with an n squared. And 15 divided by 3, that leaves you with a 5, and the n goes away. Repeating the process here on the next two. Well, look at these. It starts with a negative, so we're going to factor at a minus 2, and that's it. So the minus 2 comes out. What's left over? N squared. And negative 10 divided by negative 2. Negative and negative makes it a positive 5. Are my parentheses the exact same here? Why, yes, they are. Those are the same. So that's going to come out as an n squared plus 5. Then we have a 3n minus 2. And then don't forget what's out in front of all of it. which is an x squared. And there is your final, fully factored answer. Now for the next ones, I'm going to give you some expressions, and you're going to tell me if these are factored or not. So we're going to decide if this is factored. Now, what does factored mean? This is factored, okay, where it's all broke up with parentheses. This has not been factored. So I'm going to give you some, and you're going to tell me if these are factored or not. So are these factored already? Is this one factored already? Is there anything more I can do? Yeah, I can do something with this, right? Has this already been factored? No, it has not been factored. Why not? Why has this not been factored? What do these have in common? Do these have a variable in common? Yes. What variable could come out? X. So this has not been factored because I can break it down. So this one's not been factored because I can take out an x squared, which would then leave you with an x cubed minus 9. Right? That's why this one has not been factored. Because I can take something out of it. What about this one? Has this one already been factored? Yes or no? Yes, this one has been factored. Why has this one been factored? Because somebody already took out that 5xk. Right? So that means they already did it. So this one has already been factored. Okay, let's do another one to see if this one's been factored. You have to be very careful. Has this one been factored? Well, a lot of you are going to say that this has been factored, but it has not been completely factored. Why not? Because when you look at this second set of parentheses, do you see something that's in common? Yes. We have an 8 and we have a 4. So we're going to take out a 4 out of that. Nothing can come out of here, but we can take a 4 out of here. And that leaves you then with a 4x squared plus 3. 4 comes out of here, and that leaves you with a 2x minus 1. So has this one been factored? No. Why not? Because we could take more out. If you can do something to it, it has not been factored. So let's just do a couple of these. Let's look at question 2 from your homework. And someone can tell me, has this been factored, yes or no? Do you think this one's been factored or not? Yeah, this one's already been factored, hasn't it? Right? Nothing comes out. What about 4? Has that one been factored? Yes. What about 5? Has 5 been factored? No. Why has 5 not been factored? Because what can I take out of here? I can take out the variable n, right? So if you can take something out, it has not been factored. So that now should finish up the lecture for today. And so what do we have for our homework? Well, here's our homework. Our homework for Thursday, we finished out 4:4. You should be able to do them all. And 5.1. You should be able to do them all. All right? So I will see everyone then on Thursday. If you haven't picked up